Hello! This is our lesson 6 for week 3 in general mathematics. Future and present value of simple and general annuities. With our learning competency, the learner find the future value and present value of both simple annuities and general annuities. So let us review simple annuity. We define simple annuity as the interval is the same with interest period. In general annuity, the interval is not the same with the interest period. In term of an annuity is the time between the first payment interval and the last payment interval. And the regular or periodic payment or R is the amount of each payment. The amount or future value, denoted as F, is the sum of future values of all the payments to be made during the entire term of the annuity. And the present value, denoted by P, is the sum of present values of all the payments to be made during the entire term of the annuity. So we have here the simple annuity cash flow. So we have the present value, and at the end of the regular payments, the total is the future value. That is from 0 to end term. For example, an installment payment of an appliance of 3,000 every month for 6 months. So we have here the cash flow. First month is 3,000. Second, third, fourth, up to 6 months is 6 months is 3,000. So adding all 3,000 up to 6 months is the future value. So the future value of simple annuity immediate example is, suppose Mrs. Claverio would like to save 3,000 at the end of each month for 6 months in a fund that gives 9% compounded monthly. How much is the amount or future value for savings after 6 months? So given the problem, the regular payment, which is 3,000 pesos, and T is 6 months, then interest is 9% or 0.09, and M, since that is monthly in 1 year, is 12 months. So to find for the value of J, we're going to divide the interest into 12 because interest should be in annual. So that's 0.09 divided by 12 is 0.0075. So what we're going to find is the future value. So we have here the cash flow. 3,000 for the first month up to 6 months. So the future value of all payments at the end of the term 6 months is, at the first month we have 3,000. Since this is compounding, so for the next month we're going to multiply that by the interest rate, which is 0.0075 plus 1. Then, at the next month is squared, that 1 plus 1.0075. Then next is to the third power and to the fifth power. Or, this is, and the first month is 3,000, and the second month is 3,022, and third month is 3,045. Then, the next month is 3,068 and 3,091 to 3,114. So adding all of this, so we have 18,340 pesos and 89 centavos. So therefore, the amount of this annuity is 18,340 pesos and 89 centavos at the end of 6 months. Note that the time value of money is an amount such as 3,000 at the first month has different value than 3,000 at the second month or 3,000 at the third month, and so on. The correct way to find the total savings at the end of 6 months is to compute the maturity value of each 3,000 at the end of 6 months. So this is the future value of ordinary annuity or the annuity immediate is from the regular payment up to end power. So that is the amount of annuity immediate is given by F is equal to regular payment times 1 plus J. raised to n minus 1 over j, where r is the regular payment and j is the interest rate per period and n is the number of payment. So solution for that problem using the formula now is f is equal to r plus quantity 1 plus j raised to n minus 1 over j is substitute the value of the regular payment, which is 3,000, and the interest per period is 0.0075 raised to n is the number of times of payment minus 1 is equal to the value of over the value of 0.0075. And 1.0075 raised to 6 is equal to 1.045824 minus 1 is equal to 0.04585224 divided by 0.0075 is equal to 6.113631 times 3,000 is equal to 18,340 pesos and 89 centavos, which is the same in our computation while ago. But for this time, we use the formula in finding for the future value. So the future value after 6 months is 18,340 pesos and 89 centavos. So another, in order to save for her high school graduation, Maricar decided to save 200 in a bank at the end of each month. If the bank pays 0.25% compounded monthly, how much will her money be at the end of 6 months? So given in the problem, regular payment is 200 pesos and the number of times of payment is 12 and the interest rate is 0.25 or that is 0.0025. To find for the value of j, we're going to divide the rate into 12. That is the number of times we're going to pay in a 1 month. So that's 0.002083. So t is equal to 6 years. And n is equal to multiply 12 times 6 equal to 72. So we have the future value is equal to r plus 1 plus j raised to n minus 1 over j. So substituting the value of regular payment, which is 200, and the value of j is 0.002083 raised to the value of n, which is 72 minus 1 over the value of j, which is 0.002083. And 1.002083 raised to 72 is equal to 1.01510943 minus 1 is equal to 0.01510943 divided by the value of j, which is 0.002083 is equal to 72.535012. Multiply to 200, so we have 14,507 pesos. So this is the future value of Maricar after 6 years. Then the present value of an ordinary annuity. To find for the present values, we have b is equal to r1 minus quantity of 1 plus j raised to negative n over j, wherein r is the regular payment and j is the equivalent interest rate per payment interval and n is the number of payment. For example, Kenneth borrowed an amount of money from Kat. He agrees to pay the principal plus interest by paying 38,973 pesos and 76 centavos each year for 3 years. How much money did he borrow if interest is 8% compounded quarterly? So given in the problem is regular payment is 38,973 pesos and 76 centavos and the interest rate is 8% or that's 0.08, and m, since that is quarterly, so we have 4, then we have n is 3 payments, since that is 3 years, then we're going to find for the present value. So we have here the cash flow, paying for 3 years, every year is 38,973.76 up to 3 years. So first we're going to convert 8% compounded quarterly to its equivalent interest rate for each payment interval, since they are not the same, quarterly to annually. So we have here for the future or f sub 1 is 1 and f sub 2 is 4 because that is quarterly. So substituting the value of j, which is 0.08, divided by 4 is equal to 1.02 raised to 4th power minus 1 to get the value of I. So that is I over 1, or the value of j is equal to 0.82432 or 8.24%. So using the formula and finding for the present value, so substituting the regular payment, that is 38,973.76, and the value of I computed is 0.082432 raised to the value of n, which is 3. So we have minus 3 over 0.82432. And 1.082432 raised to negative 3 is equal to 90.78849354. Then 1 minus 90.78849354 is equal to 0.2115644748 divided by 0.082432 is equal to 2.56582971 times 38,973.76 is equal to 100,000 pesos. So therefore the future or the present value is 100,000 pesos. So what is a cash flow? It is a term that refers to payments received, or that is the cash inflows, or payment or deposits made, that is the cash outflows. Cash inflows can be represented by positive numbers, while cash outflows can be represented by negative numbers. While fair market value, or the economic value, is the fair market value of a cash flow or the payment stream on a particular date, refers to a single amount that is equivalent to the value of the payment stream of that date. This particular date is called the focal date. For example, Mr. Abaya received 2 offers on a lot that he wants to sell. Mr. Ocampo has offered 50,000 and 1 million lump sum payment 5 years from now. And Mr. Cruz has offered 50,000 plus 40,000 every quarter for 5 years. So we're going to compare the fair market values of the 2 offers if money can earn 5% compounded annually. Which offer has a higher market value? So given in the problem is for Mr. Ocampo's offer is 50,000 down payment plus 1 million pesos after 5 years, while for Mr. Cruz is 50,000 down payment, but we're going to give 40,000 every quarter for 5 years. So that is for 20 times. So what we're going to find is the fair market value of each offer. So we have here the cash flow for Mr. Ocampo, 50,000 down payment, and after 20 payments, we have 1 million pesos. And for Mr. Cruz, 50,000 down payment, and you're going to give 40,000 quarterly, so that is for 20 payment is 40,000 each quarter. So we have here for Mr. Ocampo's offer, the future value is 1 million, and N is 5 years, and J is 5% compounded annually. So we're going to find the present value of 1 million. So to find for the present value is future value plus quantity 1 plus J raised to negative N, wherein the future value is 1 million pesos, plus the value of J is 0.05 raised to the value of N, which is 5 years, is negative 5. So we have now 1 million times 1.05 raised to negative 5 is equal to 0.78352617 times 1 million is equal to 783,526 pesos and 17 centavos. So that is the present value of 1 million. So to find for the fair market value, that is down payment plus present value, wherein the down payment is 50,000 plus the present value is 783,526.17 or 17 centavos. So therefore, the fair market value is 833,526 pesos and 17 centavos for Mr. Ocampo's offer. While for Mr. Cruz offers, we're going to compute the present value of the general annuity with quarterly payment but with annual compounding interest of 5%. That is converting quarterly into annual or annual to quarterly. So we have quarterly, so that is to the raised to the 4, and for annual is raised to the first power. Wherein the given interest rate is 0.05. So divided by 1 is still 0.05. And 1.05 raised to 1 is equal to 1.05 raised to 1/4, because we're going to get the square root on the other side. So that's 1 plus j raised to 4 to get the value of j. So we have now the value of j is 0.012272. And the present value of the general annuity is, using the formula and finding for the present value, substitute the regular payment, which is 40,000, and the value of j, which is 0.012272, raised to the value of n, which is 20. That is quarterly times 5 years is 24 times 5 is 20. And we have 1.012272 raised to negative 20 is equal to 0.07835297956. And 1 minus 0.07835297956 is equal to 0.2164702044. Divide that by 0.012272. So we have 17.63935,824.64 times 40,000. So that is equal to 705,574 pesos and 33 centavos. So therefore, this is the present value of Mr. Cruz offers. So to find for the fair market value, we're going to add the down payment plus the present value, wherein the down payment is 50,000 and the present value is 755,574.33. So we have now 574.33 plus 50,000 is equal to 755,574 pesos and 33 centavos. So therefore, that is the fair market value. Hence, Mr. Ocampo's offer has a higher market value. The difference between the fair market value is 833,526 pesos and 17 centavos minus 755,574 pesos and 33 centavos is equal to 77,951.84. So for your activity 1, you're going to find the future value and the present value of the following simple annuities. So given the table, we have A, B, C, and D, wherein given is the periodic payment, the rate, mode of payment, and term. So you're going to show your solution for each item. Okay, so we're going to solve now for letter C as an example. For letter C, given is periodic payment is 5,000, while rate is 4%, and mode of payment is quarterly, and term is 5 years. So to find for the future value, so we're going to use this formula, then substitute the regular payment, which is 5,000 before. But before that, we're going to solve first for the value of J. That is to find for the value of J, rate divided by the number of payment, which is quarterly. So we have 4 times. So that's 0.04 divided by 4. That's equal to 0.01. And to find for the value of N, we're going to multiply M times T. M is the number of payment and T is the number of years. So we have 4 times 5 is equal to 20. So substitute now the regular payment, which is 5,000, in the value of J, which is 0.01, in the value of N, which is 20. So we have now 1.01 raised to 20 is equal to 1.220 19,00399. So minus 1, so we have 0.222019,00399. Then divided by 0.01, so we have 22.0199399 times 5,000 is equal to 110,095. So that is the future value of 5,000 after 5 years. And to find for the present value, we're going to use this formula. Then substitute the regular payment, which is 5,000, the value of J, which is 0.01, and the value of N, which is 20, divided by the value of J, which is 0.01. And 1.01 raised to negative 20 is equal to 0.819,544,73 and 1 less 0.819,544,4703 is equal to 0.1804555,297 divided by 0.01, which is equal to 18.0555,297 times 5,000 is equal to 90,228, which is the present value. So therefore, this is now the solution for letter C in finding for the future value and the present value. So what you're going to do now is to continue solving what are given in the table using this formula and this solution. It should be a complete solution. Okay, for activity 2, find the future value and present value of the following general annuities given the table below. So we have A, B, C, D. So you're going to show your solution for each item, but you're going to choose 2 problems only. And then for activity 3, that is problem solving, choose 1 problem to be solved completely. So we have 3 given worded problem here, but you're going to choose only 1 problem to be solved, but with complete solution. So for your reflection, what did I learn from this topic? So you're going to write what you've learned in a clean sheet of paper. And to end this, before we're going to end this lesson, let me share this quotation. Don't let your situation in life bring you down. God has bigger plans than the problems you are facing. Again, thank you for watching and listening. I hope you learn how to solve for the future and present value. Again, this is Teacher Riza saying thank you and always keep safe. Please don't forget to like and subscribe. Thank you. Have a nice day.